parabola. So we are given a positive parabola or a positive quadratic. Right? Now this is the gradient function of some function f of x. So we know if we integrate, right, we anti-differentiate, a positive quadratic becomes a positive cubic. Right, for example, x squared becomes x to the power of 3 divided by 3. Right, a positive cubic. So, spoiler alert, the question's asking, sketch the original function. We know that the antiderivative of a positive quadratic is a positive cubic. Right? So we can draw a cubic. Not quite. Right? A reminder, when we integrate, we have this constant at the end, plus c, because we don't know if it's going to look like this, going to be a bit lower, a bit higher, somewhere in the middle. It could be any one of those graphs. So we do need to be careful in that, in this case, it needs to go through the origin, the point 0, 0. Alright. So, actually quite a lot to unpack in this question. It is a merit question, but let's go through it now. So, the gradient function tells us the gradient of the original function. So, for example, at this point here, at x equals minus 2, the gradient of the original function will be 0. So that is a turning point, right? And as well as like 1 1/3, like 1.2 as well. So on our original function, in line with those x values, so at minus 2 and about 1.2 approximately, we need our turning points, because the turning points have a gradient of 0. Cool, so that's some key information. What else do we know? The gradient left of negative 2 and right of 1.1 has a positive value, right? Because on our gradient function, the y value is positive, which means on our original function, we would expect it to have a positive gradient, then a negative, and then a positive. Positive, positive. Right? And of course, in between, we expect it to be negative. Because on our gradient function, the y value is negative. Cool. Alright, so with that, we can now sketch the original function. So firstly, we know that we need the maximums, the maximum aligned with that vertical line and the minimum with this vertical line. We also know it must pass through 0, 0. So with that, we can now sketch. So it has to have increasing gradient, maximum, go through the origin, minimum, then increasing gradient again. Yep. And that would be enough for merit. So, if you just sketched a positive cubic through the origin, for example, something like that, that would be achieved. However, if you have the maximum and the minimums in line with those dashed vertical lines, you would get merit.